Good morning. In this video, we are going to continue with chapter 5, Arithmetic Progression. Sum of first n terms of an AP. To find the sum of first n terms of an AP, a plus d, a plus 2d, a plus 3d, etc., the nth term will be given by an equal to a plus n minus 1 into d. So let us take s to denote the sum of n terms of this AP. That means S will be a plus d plus a plus 2d plus etc. plus a plus n minus 1 into d. Rewriting them in the reverse order. So from the last, we are going to write the first. So S is equal to a plus n minus 1 into d plus a plus n minus 2 into d plus so on plus a plus d plus a. On adding both the equations term-wise, we'll get 2s is equal to 2a plus n minus 1 into d plus 2a plus n minus 1 into d plus etc. plus 2a plus n minus 1 into d. This will be repeated n times because there are n terms in our series. Now if we continue that way, so 2s will be equal to n into 2a plus n minus 1 into d. So s will be equal to n by 2 into 2a plus n minus 1 into d. So this is our formula. Sum of first n terms of an AP is given by s is equal to n by 2 into 2a plus n minus 1 into d. And we can write the formula also as n by 2 into a plus an, where an is the last term. We know that small letter l also denotes last term. So we can also write that as Sn equal to n by 2 into a plus l. The sum of first n positive integers is given by Sn equal to n into n plus 1 by 2. This is a special formula. We are not going in detail about how it derived, but we'll be using this formula in a few questions. So you have to learn this too. Sn equal to n into n plus 1 by 2. Find the sum of the following APs. Minus 37, minus 33, minus 29, up to 12 terms. So given that A is minus 37, D is second term minus first term, which is minus 33 minus 37. So answer is 4. N is 12. So we know that Sn equal to n by 2 into 2a plus n minus 1 into d. So S12 is 12 by 2 into 2 into minus 37 plus 12 minus 1 into 4. 6 times minus 74 plus 44 is minus 180. So sum to n 12 terms of this AP is minus 180. We are considering fractions now. 1 by 15, 1 by 12, 1 by 10 to 11 terms. So A is 1 by 15, D is second term minus first term, 1 by 12 minus 1 by 15, which is 1 by 60. N is 11. Again, we know the formula for Sn equal to n by 2 2a plus n minus 1 into d. S11 is 11 by 2 into, we'll substitute the values of a and d in the formula. N also is 11. So when we solve them, we'll get the answer to be 33 by 20. So sum of 11 terms is 33 by 20 for this AP. Now in an AP, it's given that A is 5 and D is 3, AN is 50. We have to find N and Sn for this question. So an equal to a plus n minus 1 into d, we already know because here we have to find the n. So an is 50 equal to a is 5 plus n minus 1 into d is 3. So 45 equal to n minus 1 into 3, n minus 1 is 15, so n is 16. We found n, we have a, d also, so let us substitute Sn equal to n by 2 into a plus an. You can also use 2a plus n minus 1 into d formula. Either of them doesn't matter. We have all the necessary data with us. So let us substitute 16 by 2 into 5 plus 50, that is 8 into 55, 445 is the Sn. That is sum of 16 terms. S16 is what we are finding here, isn't it? The next one, A3 is 15 and S10 is given to be 125. We have to find D and A10. So A3 is 15. That means A plus 2D is 15. Let us consider that to be equation number 1. And now S10 is 125. We know that Sn is n by 2, 2a plus n minus 1 into d. So let us substitute in that. 125 is 10 by 2 into 2a plus 10 minus 1 into d. We don't know a, we don't know d also. So we'll leave them as such. Solving, we'll get 25 equal to 2a plus 9d, which is equation number 2. Multiplying equation 1 by 2 and then subtracting. That is, we are using elimination method over here. So 5d is equal to minus 5, d is minus 1. Substituting this in equation 1, we'll get a as 17. So we got a, we got d also. A10 is a plus 9d, which is 17 plus 9 into minus 1. So 17 minus 9, which is 8. So the 10th term of this AP is 8. Now, given that D is 5 and S9 is 75, we have to find A and A9. So Sn is n by 2, 2a plus n minus 1 into D. 75 is 9 by 2 into 2a plus 9 minus 1 into 5. We have to find A over here. So we'll substitute, solve it, and finally we get A to be minus 35 by 3. We know that an is a plus n minus 1 into d. So a9 is minus 35 by 3 plus 9 minus 1 into 5. When we solve it, we'll get the answer to be 85 by 3. So in these type of questions, we are using both an formula as well as sn formula in order to find the answers. Now the next one, an is 4, d is 2, sn is minus 14. Find n and a. We know that an is a plus n minus 1 into d. The value is going to be 4 equal to a we have to find out, and also we have to find out d is 2. So we form the equation a is equal to 6 minus 2n, which is equation number 1 for us. Now we know that Sn is n by 2 into a plus an because we know the last term, so we are using the last term formula. Minus 14 equal to n by 2 into a plus 4. So minus 28 is n into a plus 4. Now we know that a is 6 minus 2n. We are substituting that. Then we form a quadratic equation. 2n square minus 10n minus 28 equal to 0. Throughout we can divide by 2. So n square minus 5n minus 14 equal to 0. We are using factorization method. Minus 5n can be written as minus 7n plus 2n. So n is taken common out, n minus 7 plus 2 taken common out, n minus 7 equal to 0. N minus 7 into n plus 2 equal to 0. So n is 7 or n is minus 2. However, n cannot be negative or fractional. We saw it in the previous question also. So n is 7. From equation 1, we obtain that a is equal to 6 minus 2 n, which is 6 minus 2 into 7, which is minus 8. Now, find the sum of first 51 terms of an AP whose second and third terms are 14 and 18 respectively. A2 is 14, A3 is 18. That is given to us. So D is A3 minus A2. We can subtract any consecutive terms of the series. So 18 minus 14 is 4. A2 is 14. So A plus D is 14. D we know as 4. So A is 10. We got A and D. Now we have to find the sum of first 51 terms. So S51 we have to find out. We know the formula Sn equal to n by 2, 2a plus n minus 1 into D. We'll substitute the values of n, a and d in the formula. After solving, we arrive at the answer 5610. If the sum of the first 7 terms of an AP is 49 and that of 17 terms is 289, find the sum of first n terms. General sum they have asked here. Given that sum of first 7 terms is S7, which is 49, and the sum of first 17 terms is S17, which is 289. So let us substitute the formula Sn equal to n by 2, 2a plus n minus 1 into d. S7, we are substituting. We arrive at the equation after solving 7 equal to a plus 3d. That is equation number 1. Similarly, S17 also will substitute. We arrive at the equation 17 equal to a plus 8d, which is equation number 2. Subtracting both the equations, a would get cancelled. We are remaining with 5d equal to 10. So d is equal to 2. From the first equation, we get 7 equal to a plus 3 into 2. So a is 1. Now we have to find Sn, the general form, isn't it? So we'll substitute the formula n by 2 into 2a plus n minus 1 into d. So we are not going to substitute for the value of n because n we don't know. We are asked a general answer. So n by 2 into 1 plus n minus 1 into 2. When we solve, we get n square because 1 and minus 1 will get cancelled. So we will get n square. Okay. So Sn equal to n square is the general formula to find the sum. So when you're having the general formula, if you're going to substitute S1, 1, that is the sum of first term. So that is how it works. Now the next one, show that A1, A2, A3, etc. form an AP where AN is defined as AN equal to 3 plus 4N. Also find the sum of first 15 terms in each case. Given that an is 3 plus 4n, so let us find the terms first. We substitute 1, so a1 will be 7. Substituting 2 for n, a2 is 11. Similarly, a3 15, a4 19. Now we have to check, consider a2 minus a1 is 4, a3 minus a2 is 4, a4 minus a3 is 4. The difference is same throughout, therefore it is an AP with the first term 7 and common difference 4. We know that Sn is n by 2 into 2a plus n minus 1 into d. So S15, we substitute n15, a as 7 and d as 4. So when we solve, we get the answer 525. That is the sum of first 15 terms for this AP. Now moving on to the 11th question. If the sum of the first n terms of an AP is 4n minus n square, what is the first term? What is the sum of first two terms? What is the second term? Similarly, find the third, 10th and nth terms. Given that Sn is 4n minus n square, in the previous question we had an, here we are having Sn, so let us substitute. 1 will get the first term, S1 equal to 3, which is the same as the first term A. Sum of first two term means S2. So we'll substitute 2 in the general form, 4 into 2 minus 2 square, which is equal to 4. Now second term is S2 is sum of first two terms. S1 is sum of only the one term. So when we subtract that, we will get the second term. So A2 is S2 minus S1, which is 4 minus 3, 1. Now D is A2 minus A1, which is 1 minus 3, which is minus 2. So we got A, we got D also. We know the AN is A plus N minus 1 into D. So A is 3 plus N minus 1 into D is minus 2. So we get the general form AN equal to 5 minus 2N. In this, if we substitute 3, A3 is equal to 5 minus 2 into 3, which is minus 1. A10 is 5 minus 2 into 10, which is minus 15. So the sum of first two terms is 4. The second term is 1. The third, 10th and nth terms are minus 1, minus 15 and 5 minus 2n respectively. So all the questions that had been asked in this question are answered. Now the 12th question. Find the sum of first 40 positive integers divisible by 6. In the previous video, we had seen how many terms are divisible by 7. Similar kind of question. Here we have to find the sum of all those numbers. So the positive integers that are divisible by 6 are 6, 12, 18, 24, etc. It can be observed that these are making an AP with the first term 6 and common difference 6. Sum of 40 terms, that is S40 is what we have to find out. SNS, n by 2, 2a plus n minus 1 into d formula. So S40 is 40 by 2 into 6 plus 40 minus 1 into 6, substituting for a and d. Solving, we'll get 4920. These are the sum of first 40 positive integers which are divisible by 6. So with this, we have come to the end of this video as well as the end of this chapter. Thank you.